Refining. The metal extracted by any method is not having only metal atoms, but along with have atoms of other metals and non-metals in varying quantities. So, depending upon application, different levels of purity in metals and semiconductors is required depending upon their applications. We have to further purify these metals, whatever we have got from the last steps. After concentrating it, after we have purified to some extent by roasting or converting into oxides, and further we have gone electrolytic methods has been used, but still we have not acquired a quality or purity of required for application. So for that, refining is required. Refining is a process of reducing unwanted impurities in a desired elements to the required level. So what are the refining techniques we have in our hand? Distillation, liquation, electrolytic refining, zone refining, chromatographic methods, and vapor phase refining. Here let's discuss all these techniques one by one. First, distillation. This is applicable for the low boiling metals like zinc, mercury. Impure metal is evaporated to obtain pure metal as distillate. We heat up these impure metals. Pure metal vaporizes because of its low boiling points. And finally, we cool it and got pure metal collected. Zinc and mercury are purified by this simple distillation techniques. Other are liquation. In this method, a low melting metal can be made to flow on a slope surface that is heated. It is possible only for the elements in which the impurities having a very high melting points compared to our metals of interest. So, it will be having a heating slope. We put an impure metal here and we then heat it up. What happened next? We started getting pure metal flowing down because of its low melting point, and impurities still stuck up on the slope. Next is electrolytic refining. Just we discussed, like in this, impure metal is used as a anode, positive charged is impure. Pure metal is used as a cathode, a thin strip. Now they put in a suitable electrolytic bath. For copper it may be copper sulfate aqueous solution. When we pass a current through the circuit, what happens? This impure metal get ionized, we getting copper 2 positive here, and it start moving toward our cathode, which is negatively charged, and get deposited here and reduced. Electrons are supplied by the external circuit. So ultimately what happens? Impure metal got totally consumed. We getting an anode mud, all impurities settle down below the anode, and this metal got thicker and all pure. This is pure zone refining. It is used for the purification of semiconductors like germanium and helps to attain very high levels of purity. This method is based on a principle that impurities having a high solubility in melt than in solid state of metal or semiconductor. We heat it up slowly, a rod, this is germanium rod, and then it melts. When it moves, molten zone creates impurity that moves down along the heater. What happens? This molten keep on taking the impurities from the solid phase. So this process is repeated again and again. The pure metal crystallizes at its back and passes to the adjacent zone. So this is the way this impurity, this last piece will be cut down by removing it. And the same process will keep on repeating. So that finally we get a very high purity germanium. Remember the concept. Impurities are more soluble in melt than in solid. Vapor phase refining. This method works on the difference in the volatility of metal compounds and with other impurities. Metal is converted into its volatile compound and collected elsewhere. Then it is decomposed to give a pure metal. Vapor phase refining. Metal should be formed volatile compounds with the available reagent. Volatile compounds should be easily decomposable so that can be recovered easily. First, Mond process of vapor phase refining. Nickel is purified this way. It's a crude nickel. It is crushed. And here is a carbon monoxide. Feed it. And here it's converted into nickel carbonyl complex at around 350 Kelvin. Nickel tetracarbonyl then fed to another chamber for decomposition. Here it is decomposed on heating is 100 Kelvin higher. So as a pure nickel and carbon monoxide is fed back. So this is a simple technique, Mond process of purification of nickel. Same Van Arkel method of refining. It's again a vapor phase refining process. Remember, both Mond process and Van Arkel method are vapor phase refinings. In this we use iodine. In Mond process it was carbon monoxide was used. Zirconium, impure metal, converted into its iodide, 870 Kelvin. Around 1800 Kelvin it breaks up to give us a pure Germanium. Iodine goes out. Titanium metal gives us the iodine, tetra iodo compound of titanium at 1700 degree Kelvin. It breaks out to give us a pure titanium and iodine goes out.